The next example we're going to look at involves aeroplanes and lightning. If you want to have a look at this video, feel free to do so. I'll put the link in the comments. But I'm going to jump right into the question. So here's your example. A plane leaves an airport in a westerly direction. The plane takes off at the end of the runway, which is at the origin. It flies kind of diagonally upward until it is 5 kilometers west of the runway and 600 meters in the air. This is the point A. After it reaches point A, it then begins to fly in a horizontal direction until it is 9 kilometers west of the end of the runway and 600 meters above ground at point B. First, notice here, we have kilometers and meters. Always swap it to 1 unit. So either meters or kilometers. I'm going to choose meters. After I did this question, I realized it was probably nicer to do kilometers, but really it's up to you. Let's stick for meters for now. A plane is then struck by lightning at point B, and it must descend to the same runway as it came from as quickly as possible by taking the most direct path called BO. We're going to sketch this situation. So let's have our 2D plane. This is a 2D question. We know where east is, west is, and then my vertical axis will be how high or low the plane is to the ground. So remember, the plane takes off at the point 0, 0, or my origin. It then goes in a westerly direction, so to the left. It flies until it is 5 kilometers west of the runway. So my X distance, and it's also at point A, 600 meters in the air. So I'm going to put that point in. I'm also going to put the vector in, and I'm going to call this vector from the origin to A, OA. We then notice that the plane heads horizontally. Okay, so that means it goes flat along a straight line. It continues to go west until it's now 9 kilometers past our point 0, 0. It remains 600 meters above ground, and when it reaches this point is called B. So now I have another vector, A, B. So the plane traveling this distance of the second part of its journey. At the last part of its journey, the plane turns around and heads back to the origin as fast as it can after being struck by lightning. So go the most direct path from B to O, and you'll find that's a straight, again, kind of diagonal line. This is called BO because the plane is flying from point B back to point O. Now we've done that, we need to write OA and AB as column vectors and in component form. Because we're going to the left, remember it will be negative 500 meters, and we're going up, so positive 600 meters. Of course, if you did this in kilometers, it will be a different vector. If you change it to component form, you just put the minus 5,000 I plus 600 J. Find vector AB. Well, again, we're thinking of what I have to move to go from point A just to point B. So to go from 5,000 meters west to 9,000 meters west, I would have to move 4,000 meters. And because the plane is horizontal, okay, it stays in the same place, I'm not changing my vertical height at all. So that can stay 0 of my second component. Okay, I can write this as minus 4,000 I plus 0j, or just minus 4,000 I. Last question, how far did the plane travel in total flying from O to point B? We have to calculate the length of the flight from O to A, and then add on the distance traveled of the flight from A to B. So we use our modulus formula. The length of OA would be minus 5,000 meters squared plus 600 meters squared. And the length of AB, well, again, you just take the two components, so minus 4,000 squared plus 0 squared, well, we can just leave that out. Take the square root of these. In an exam, try to leave this in an exact form if possible, okay? I'm just going to round because I forgot my calculator, and the calculator I'm using doesn't leave it in exact form. In terms of meters, we approximately get 9035.87 meters. Again, try not to round if you do not have to. It says write the vector BO as a column vector and in component form. Remember, I'm starting at the point B and going back to the origin. Horizontally, I'm going to need to go right, and vertically, I'm going down. First component should be negative 9,000 meters because we're moving 9,000 meters right or east. And the second component should be a negative 600 meters because we're moving 600 meters down to reach the origin. What is the distance traveled by the plane on the return trip? So I know that BO can be written in component form 9,000I minus 600J. To get the distance of the length of this vector, we simply take the square root of 9,000 squared plus 600 squared. We get this distance as 9,019.98 meters. Final part, we've got to calculate the difference in the distances traveled when the plane was going to point B and then back from point B to O. Just subtract our distance from O to point B, which was 9.036 kilometers or 9,035.87 meters, with the distance from B back to O. So we're going to subtract 9.020 kilometers or 9,019.98 meters. In the end, it's only a small difference of 15 point, about 89 meters. So have a go at 20B, and remember, if you shoot for the moon, even if you miss, you'll land among the stars. And just avoid the lightning if you can.